Hello, in today's video we are talking about multiplayer gaming, client-server interaction, and lag. Based on a 2013 study, 1.2 billion people are playing games worldwide. 700 million of them play them online. So the question is, how does this all work?
Typically, most modern games employ a client-server model. There are two types of game servers, authoritative and unauthoritative. Authoritative servers are dominant over the game. Clients have to ask permission to do certain things, like moving or firing a weapon. The server then decides whether it's illegal or not, and if so, tells the client and all the others if it can perform that action. An unauthoritative server are the complete opposite. The client doesn't have to ask permission. There's one authoritative version of the world held on the server.
So, each client machine sends a regular stream of packets to the server, where each packet would contain a simplified update of the player's input. Each tick, the client might send a mouse position or keys pressed. This is a low bandwidth stream. Simulation code takes these input streams, simulates motion, and resolves them into character or vehicle positions. This simulation can run both on the server and on the client.
Having received the input packets, done the simulation, the server sends out packets containing an authoritative version of all the client's positions. In most cases, this will precisely tally with what the client thinks. These client positions only relate to mobile objects. All the static objects are never updated. Let's talk about latency. In the time it takes for the message to arrive, things will have moved. To cope with latency, server code has to play tricks with time. When someone shoots a gun, we have to consider what they were pointing at back at the point of shooting, and not looking at the world state now.
Latency causes lag, and nowadays every gamer has experienced some sort of lag during online gameplay. Lag is a delay that happens since the player sends the action of shooting, jumping, or ducking to when he or she receives a reaction from the server of shooting the bullet or avoiding the hit. In the majority of cases, the server packets will reconcile with simulations performed on the client, but when the two disagree, the server's version is considered authoritative.
In the original video game Quake, an old FPS multiplayer, you felt the latency between your computer and the server. Press forward and you would wait however long it took for the packets to travel to the server and back to you before you would actually start moving. Press fire and you would wait for that same delay before shooting. So now in order to remove the latency, the clients run more code than it previously did. It is no longer a dumb terminal sending inputs to the server and interpolating between states sent back. Instead, it is able to predict the movement of your character locally and immediately in response to your input, running a subset of the game code for your player character on the client machine.
Now, as soon as you press forward, there is no wait for the round trip between client and server. Your character starts moving forward right away. Round trip time. It's an essential concept to understand the nature of networking communications. It is defined by the amount of time taken by a packet of information that is sent from a client to get to the server and returned to that client without considering the processing times. So basically, looking at this picture, let's say the client shot another character with a gun. The time for that action to send to the server and the time for that action to be received by the client is the round trip time.
How round trip time affects lag. Say we have two people, Mary and John, playing a Western shootout duel game. They have different round trip times with the server. If John has a shorter RTT than Mary does, his actions will get there before, and therefore the server will react before for John than for Mary. In this example, even though Mary sends shoot earlier in time than John does, due to John's RTT being much shorter, in this case client to server, than Mary's, the server receives the shoot action by John first, and in consequence Mary's hit. This is according to the server. We will explain this problem in detail near the end of the video.
We have just finished explaining what lag is. In conclusion, what server does is that it has authority over the game and game rules. It receives client moves and requests, it verifies legality of moves and requests, it sends game data and player data to all clients, and depending on the game and type of device, the server may do a lot of heavy lifting as far as graphics, computation, and physics.
Let me explain to you what a client does. A client receives user input, sends moves and actions requests to server, updates games states based on received states from server, interpolates frames by predicting changes in game or player movements. This allows for smoother gameplay, especially in FPS style games. This is how multiplayer games works.